Today we're going to talk a little bit about database design. So in chapter 5, we discussed what data processing is, what is a database, what is a database management system, and why do we need databases and the purpose of them. What we want to get to today is, hopefully you've seen the value in a database, but how can we create one, right? And that's where the design process comes in. So let's imagine for a minute, and this is the case at the beginning of chapter extension 4 out of Experiencing MIS. But imagine you're in charge of a fund drive, and you are trying to raise money over 6 nights, and you need volunteers who can man the phones each of those nights. And this is very intensive and exhausting experience. So usually you can get people to do it for one day or one night to do this. So you get 10 people per night, so 60 total volunteers you need for this fundraiser. Now, what usually happens in the past was that you'd have to collect a bunch of names of volunteers from the previous people that ran the fundraiser and start calling people. Now, and that's fine. You can have lists of volunteers, but you don't always know who you should call first to try to get, kind of your ringers, the people with lots of experience or who are very effective at getting, getting people to donate money. So what you want is more information than what's currently out there. So you're not just randomly calling people and hoping upon hope that you get a good set of 60 volunteers. You would like to find the best volunteers who can bring in the funds in the most efficient manner. So what you need is a database. Now, how do you go about creating that? And that is the series of questions we're going to ask today. So we looked at who will volunteer for, and we'll come back and talk about this later, how we can actually design a database for this. So that'll be the last thing we cover today. But in between that, we have a series of other 4 other questions. Number 2 was, how are database applications developed? What are the components of the entity relationship data model? How is data model transformed into a database design? And what exactly is the user's role? Because that is going to be you when you go out into the business world, assuming unless you're in information systems, in which case you may be the one creating it. But let's not jump ahead of ourselves here. All right, question 2. How are database applications developed? Well, it generally goes through a process, and it starts with something called requirements. What are the requirements? What are the things that we need in order to make effective business decisions? Now, this is going to be a series of forms, reports, or queries that are commonly used on a day-to-day basis. And what are the items in each of these forms, and what are the items in each of these reports that are required for me to make a good decision? So that's where it starts, is with the requirements. You have to gather all the requirements up. And once you have those requirements, then you can create a data model. Okay? And now this data model, and we'll get to this in a minute, is composed of entities and relationships. And we saw a little bit of that in chapter 5, but we're going to dig into it a lot more. Once you have a data model, then you can actually create the database design, which is the actual tables and keys and foreign keys and all that stuff to actually create it. So you actually have to create the design of it, and then you go and make the actual thing. Now, what's interesting is that when you create a data model, you'll see that it's very similar to the database design that's actually going to be implemented in the database. And that's on purpose, but we differentiate these because we want to be sure that we're capturing the right information in the right format. Okay, so we start at a slightly more abstract level as what is the data model? What should it look like? And just because it should look like that doesn't mean it's going to look like that, because there might be some inherent limitations in the database that prohibit you from actually designing it the way you may want. Or you might find that when you go to actually design the database, that the data model isn't designed as efficiently as it could be. And that can lead to data integrity problems, and oh my God, we won't go into what that can do to you, but whew. All right. So let's move forward here. How are database application systems developed? Well, it has to start with the users. Again, you guys. And we'll come back to this again in question 5 as to, where do you fit into this? Well, number one, the users have to identify and develop requirements for the applications. And this can be also, you can also look at existing forms, reports, queries, and other activities that the users use on a daily basis. So then you summarize all these requirements and start looking for themes that are going to become your data model. Now, what kind of things? These are major types of transactions, things that the user must work with. Okay. Once this data model is sketched up, then what happens is that a database designer will take that model back to the user and have them validate it and say, does this seem right? What can we do to, and identify all the things that are in it, and is this right, is this right, is this right, is this wrong, is this wrong? What should we do here? What about this and this and this? And so there's a conversation that has to go on here. It's not a one-sided thing, right? Because if it was, guess what would happen? You wouldn't get what you need, right? So it's very important that the users review and validate the data model and eventually approve it once they've gone through this review process. And sometimes this takes multiple iterations. Then, once it's approved, you can actually build the database. So what's going to go into this? Well, first off, in the data model, there's something called an entity relationship diagram or entity relationship data model. So what are entities? Now, I think I mentioned this in chapter 5, but entities, you can think of them as essentially as nouns, things, something the user wants to track, something that the user wants to track. See the word thing? That's a noun, right? Now, this might be something like an order, might be a customer, it might be an employee, it might be a volunteer, it might be any host of items, right? The attributes describe the characteristics of the entity. So these are your adjectives, right? So for an order, you might have an order number, you might have the customer number, you might have the date that it was ordered, you might have whether or not the order has been fulfilled, or if the order has been paid. Okay? For a customer, you're going to probably start with a customer number, but you might have their address, their phone number, their and when address could be multiple fields, and also include zip code, state, country. Could include their email address, and so on. For a volunteer, what types of things might be useful for a volunteer? You need to know their name. You might need to know their phone number, maybe even a description of their description of the volunteer. I don't know. Depends on what are their skills and strengths. And entities have to have some sort of identifier, something that makes them unique. Now, sometimes there's something inherent with your attributes that can become an identifier. This isn't always the case. So, for example, someone might say, well, what about a person's name? Can that be an identifier? Well, chances are no, because two people could potentially have the same name, or at least the first name and last name. What are you going to do then? Well, now they're not uniquely identified. So this is very important when it comes to database design, is that you have to have something that uniquely identifies the entity. And if one doesn't naturally exist, then the database designer has to create one, basically make one up. So, you might have a student. Well, we all have, all of you students have student ID numbers, right? You have your pirate ID. Your pirate ID is unique. Everyone has a different one. Even if you might happen to share the same first and last name with another student on campus, you have a unique pirate ID. So, like for an example here, if we're looking at different, a student a database for students and their advisors, it might look something like this. You might identify you have students, you have advisors, you have email, you have departments, you have office visits. Okay. Now the office visit is an interesting one because that's really more of a activity that you've done, right? You might say, well, an office visit. Well, the visit is a verb, but you can specify specific instances when they did visit and record something about it. So that's why it's listed as a separate entity. But the rest of them are pretty obvious. All right. Now, in this case, they have a student, the student name, student number, and then they have homework 1, homework 2, midterm. Now, this may not actually be the best way to develop this data model if you're looking for the relationship between a student and their advisor, because they're going to have lots of different homework assignments from a lot of different classes and probably a lot of different types of classes, so the homeworks and midterms are not going to be consistent across students. So really, if you're developing a database that keeps track of the students and the advisors, you're not going to want these attributes. So depending on the context, you're going to focus on different attributes. What might be a little bit more appropriate? Well, maybe the student name, but maybe you could include their GPA. And yes, that does change over time, but all students have a GPA, and that's something the advisor might need to know when they're advising a student. Or maybe their year in school, or their financial background, or are they on financial aid or something? I'm just making stuff up here because I'm trying to brainstorm it on the spot, but these 3 items, the homework 1, homework 2, and midterm, may not be the best options. All right, moving on. We've identified entities. The next part is to identify the relationships between them. Now, this can vary from place to place, but let's say, for example, that a department may have many advisors, but an advisor only works for one department. Now, I don't think that's quite how it works in the College of Business here at ECU. I believe here we have multiple advisors at the college level, not the department level. But you get the point, right? So a department may have many advisors, and an advisor works in one department. So what we have is a one-to-many relationship. One department can be related to many advisors, but an advisor is only related to one department. Now, you could also end up with a situation where an advisor advises many students, but a student may have one or more advisors. So this might happen if the department allows students to meet with multiple advisors. So the student can pick who they want to advise with. Or maybe they change advisors each semester. And you want to keep track of who they've advised in the past. So if that seems a little confusing, another way of looking at this is sketch out the relationship between the specific entities. So if you actually write out the entities, so suppose there's 2 departments, accounting and finance, and they have multiple advisors. And so you list out the advisors and who they're related to as far as departments go. And then you list out the students and see how the advisors and the students relate to one another. Now, it might be the case, and this looks like it is this time, that if a student has a double major in accounting and finance, they may have 2 advisors, one for accounting and one for finance. that's when you can end up with an end-to-end relationship, where it's many students can have up to many students, and many students can have up to many advisors, and advisors can have multiple students. So how would we write this out in the data model? Well, the data model starts by identifying the entities. So we have a department entity in blue, an advisor entity in this golden color, or kind of brownish color. I don't know how it looks on your screen. And then you have the student entity in the orange color. And under each one of those, I have the attributes. Department name, phone, email for department. For advisor, you have an advisor. Probably could even be more specific and say advisor name, phone, campus address, email address. And for the student entity, you have student number, student name, homework 1, homework 2, midterm. And if you really wanted to be precise, you would also identify which of these is the unique identifier. And you can separate that out by drawing a little line underneath of that you'd put the unique identifier at top and put a dark line underneath of it. Right? I have not done that in this diagram, but your book shows some great examples of this. And you start off by drawing lines between them. Okay, so the relationship between department and advisor, and relationship between advisor and student. Now you might be wondering, isn't there a relationship between student and department? Well, not in this database, there isn't. Now there might be a situation where you would want to have that relationship, but in this case, no, we're not. Kind of the central, most important entity in this case is the advisor itself, because they're the one that pulls everything together. Now, when we go to identify how these relate, we can write, or you can put in these little triangles, so it's kind of a three-way triangle, at the end of each line. So you see very carefully, I've added an between department and advisor, the dark line, there's a little triangle on the advisor side. And what some people might call it like a crow's foot or a chicken foot, right? 3 little lines plugging into it. And the same thing from advisor to student. So what this basically means is that the department can have many advisors. That's all it means when you put these 2 lines, angled lines like that, the little crow's foot. Same thing with advisor to student. Advisor has many students. Now if I flip that and put those crow's feet on the other side, what this means is that an advisor can have many departments. Well, we already talked about that's not the case. So this would actually be incorrect. An advisor cannot have many departments. So this line, the way this notation is working, is incorrect. However, a student can have multiple advisors, particularly if they have multiple majors. So this does work. So really what we want is something like this. So a department can have multiple advisors. An advisor can only have 1 department. An advisor can have multiple students, and a student can have multiple advisors. Now you can even get more complex than this. So, and I believe they showed this in the book where you can start talking about cardinality, and they show a maximum and minimum. So an example of this would be if you have, an advisor must have 1 department. A department can have between 0 and many advisors. So it is possible some departments don't have any advisors. An advisor, especially if they're just starting, may not have any students yet. Or maybe that they were advising a bunch of students who were all seniors, and the seniors suddenly graduated. Now the advisor has no student advisees. Right? But a student, in order to be a student, must have at least 1 advisor. If they don't, there's a problem. Right? So that case, you'd put the line down here, which basically means 1, and they may have many. So 1 to many advisors. So why am I going through all this? Showing you how to create entities and relationships and all that stuff. Well, because part of your job when you're working with people developing databases is to help them identify the entities and those relationships. You need to be able to answer these types of questions. How many is acceptable? Are there any exceptions? Are there any times where an advisor won't have a department? If that's ever true, then you can't say that each department or each advisor must have one department. And so this is going to vary by where you go. Different organizations are going to have different sets of rules. And so these data models are going to change for each organization and their own specific rules. All right. So how is it? And we want to talk a little bit about this so you have a vocabulary to talk with the IS people. All right. How is the data model transformed into database design? Now this gets into something a little trickier, and there's even courses on that. A big part of it is learning how to do something called normalization. Which is essentially converting poorly structured tables into two or more well-structured tables. So what's a poorly structured table? Well, a poorly structured table might be one where data is repeated in such a way that you could split it off and put it into a separate table. All right? So your goal is to construct tables with data about a single theme or entity and to minimize something called data integrity problems. What are data integrity problems? Well, data integrity problems produce incorrect and inconsistent information. It may not always, so if you have a potential data integrity problem, which means especially if the database is not normalized, you may not have the problem yet, but it could occur. When you do have a data, so that's a potential data integrity problem. A real data integrity problem is when you have incorrect or inconsistent information. So the integrity of the data is not correct. So users will lose confidence in the information when that starts to happen. Right? Now, to be clear, this is a major problem in a lot of databases. It's not a unique situation. However, database administrators and IS people have worked really hard over the years to get better and better at this to reduce the amount of data integrity problems. Now, one way this can occur is if data are duplicated. How so? Well, here's an example. Here's a poorly designed employee table. So suppose this is our advisors, right? And the department they're associated with. And let's say we didn't have a separate department table, that we combine the advisor and the department table into one. So you have their name, you have their hire date, email, department number, and department name. And that may work great until something happens like two departments combine and make one department. I mean, yes, this does happen. Organizations do change over time, right? So that means their databases have to change to reflect that. Now, what can happen, what a potential problem with this is that when you start making your change, you change some of the fields, but not all of them. So you can think of it as, let's suppose our employee named Green, who was hired on July 17th, 2007, but for whatever reason is no longer with our company. So when you went into the database to change the department name, you only changed it for the current employees, not previous employees. And so these kinds of little problems happen all the time. And so you look at it and, 95% of them change correctly. Maybe 99% of them change correctly. But it's that 1% that may not cause a problem right away, but later maybe you're running a report and you want to see the history over time of the accounting and finance department. But it leaves off employees like Green because their department name is different. Now, so this is a problem. So how do you go about fixing it? Well, you create, because there's two themes here essentially, the employee and the department, you would split them off into two tables. So to normalize it, so the big fancy term there, normalize, basically means we're going to try to reduce the redundant data. And so now if we change the department name, there's one department place, we change it and it automatically will update. So the employees automatically reference the department number. So even if that department name changes, every employee associated with that number is going to change too. Automatically, no thought on your part. All right, so that's the idea of normalization. Now, generally speaking, you're not going to have to do a whole lot of that yourself. However, knowing this process can really help you thinking through what is the theme of an employee versus a department. So if you're trying to identify entities, this can help you do that by realizing, all right, are we going to have redundancy in our data set? If we are going to have redundancy, like if you look at this employee table, department name keeps repeating, accounting, accounting, accounting. And suppose we had 1,000 employees in there, how many times would accounting show up? If it's the exact same piece of data showing up many, many, many times, that's probably a problem. And in fact, in this case, it was. So this reduces redundancy, but we can still access the information through our relationships. So the department number foreign key in the employee table points to the primary key in the department table, and now we have the relationship established. So more on transforming a data model into a database. Well, keep in mind we want to represent each entity with a table. There must be an identifier, and that becomes the table key. And the rest of the attributes become table columns. We need to normalize the tables as necessary and represent relationships, which we use with foreign keys. And as the book describes in more detail, I'm not going to dig into it right here, you have to add additional tables if you have a many-to-many relationship. And so by doing all of these steps, you take your data model, you make your database design, and then you can create your database. All right. So what is your role, the user of these databases, right? So you are basically going to be the final judges of what data should be in the database and how tables should relate to one another. So that relationship part. You know, so I went through all those different types of relationships you can have for a reason here, because you need to be able to identify. All right, can we have 0? Can we have 1? Can we have more than 1? Does it have to be at least 1? These are the type of questions that relationships between entities that you have to be able to identify and think about and know. And so users then can review the data model to ensure that it accurately reflects their view of the business. And why do you want to do this? Because if you screw up, it's 10 times more expensive to fix a bad data model than it is to spend time figuring this out to begin with. Got that? 10 times more expensive to fix a problem than it is just to do it right to begin with. And maybe take a little bit of your time, but it's worth it. All right. So we talked a little bit about database design here. So let's go back to our volunteer discussion for our fundraiser. Now we said we need to have prospects. And what do we need to know about those prospects? Well, we need to know their work history, right? We need to know when was the last time they volunteered for us. We need to know the hours that they worked, the notes, phone calls, total donations that they collected, the average donation they took per phone call. All of these things Well, these are already, we've identified two entities, right? The prospect, so that's their name, their address, and so forth, and their work. Because they may have done work multiple times if they volunteered multiple times in the past. We also need to know, do they have any relationship with existing employees? Because then we can have certain employees call based upon who they know. And so if a certain employee has a contact with a prospect, so we need to have not only the prospect's address, but we need to have the contact information. You know, who contacted them last year and talked to them and got them to do it. So here's a data model, a potential data model for our volunteer database. Right? So we do have a prospect, and every prospect may or may not have worked in the past. Right? So you could have a new prospect who hasn't done any work, or said, last time you called, you called them in the past and it said, well, I can't do it this time, but call me in the future. Right? But every time you have a piece of work, well, work has to be associated with a prospect. Right? So a prospect may have many works, but their work or their volunteer time or whatever you want to call it, references the time they came last time to do it. So in this case, there's actually, the identifier is actually two fields, their name and when they actually came to work. Now you might say, well, why is there multiple phone numbers? Okay, so the prospect might have, well, you can think of a prospect might have more than one phone number. They might have an email. I mean, they might have a mobile phone, home phone, work phone. Who knows what else, right? And then you have the contact information. So who contacted them? So there must be. So if an employee contacted them in the past, we can keep a record of that. So now we have some sort of working data model for this volunteer database that'll allow us to solve a lot of the problems we were having with our prospects. And hopefully allow us to capture and contact and have these, I shouldn't say capture is the wrong word, but help us to identify the right prospects for this fundraiser. And so also realize that this might be an iterative process. Right? So when you first do this, you might look at it and come up with a data model that leads you to this type of database design, where you have a prospect, phone, contact, work, and employee. The name is your identifiers for the prospect, the name, phone type for the phone number, and so on. So the underline means that you have a table key. Italics means it's a foreign key. Underline and italics means both table and foreign key. So like the word name refers to the prospect name, and it shows up as both a foreign key and as a table key. Ooh, it's getting confusing, but it can be done. Now you might be looking through this and realize this is not necessarily the best way to go about identifying. Maybe because there might be prospects with the same name, so you add another second iteration to do your table design and say, all right, I'm going to take the prospect name and leave it as an attribute, and we're going to make a unique prospect ID. Maybe it's probably auto-generated by the database itself, so we don't accidentally repeat the same prospect ID. And then we can use that as a key, so there's no duplicate records. And once you have your table design, now you can go about creating your actual database. And so you might end up with a form that looks something like this. So here's a form that contains a whole lot of information about this prospect. Like a name, Mary Smith, her various phone numbers, the contact, when did we contact her, by whom, and the history of their work. Pretty cool, huh? So now we got a powerful tool that they can use for the fundraisers to help identify good prospects. All right, well, here's what we did today. We talked about the need for understanding database design so that way we can solve problems as they roll towards us, right? We started with a volunteer database for a fundraiser. We talked about how database application systems are developed, the process, and what a big component the users are. We also talked about what are components of the entity relationship data model, right? So the whole modeling thing again, we're back to another model. But we looked at entities, which are basically things, nouns for the most part, and the attributes, which are basically adjectives describing the noun. Right? Now, there are exceptions to that. Not all entities are going to be nouns. Sometimes they can be verbs. But you get the point, right? These are major things that a user is interested in. We then talked about how a data model is transformed into a database design. And that requires going about identifying normalization to avoid data integrity problems. Talked a little bit about the user's role. That's you guys. What is your role in this process? And if you're developing your own personalized database, everything, you need to know all the parts, right? But if you're working with an IS professional, you still have a major component to play in making sure and identifying those relationships, those entities, getting the cardinality down, maximums and minimums of how the entities can relate to one another. There's actually quite a bit going on there, and it's your job to help identify what's the right way. And when you have that, you can actually, as we saw at the very end, go through the process of creating a database that can help solve real-world problems. Well, that's it for today, guys. I hope you enjoy, and I'll catch you next time.